Okay, for example 1, we need to find the derivative of the inverse at this given value. So for our first problem, over to the side, keep in mind that a is the particular value that we're talking about. And so if we want to find the derivative of the inverse at 7, then that's going to be 1 over f prime of f of 7. That's what we need to keep in mind. Now here, what we need to do to find that inverse value is to really set our function equal to 7, because this is the y value on our inverse. So here, I left off my inverse sign. So over here, we're going to set our function itself equal, because really this is not an x value for the inverse, it's a y value. So we're going to say 7 equals x cubed minus 1. So we're going to add 1 over. So we have x cubed is 8. So x has to be 2. So now I know that value. We can continue the process and say, well, now I need 1 over f prime at 2. And so now we need to find f prime at 2. So we need to first find f prime at x. F prime at x is 3x squared. And so f prime at 2 is going to be 3 times 2 squared. And that's going to give us 12. So now we're ready to write our final answer, which is going to be 1 over 12. Okay, so for number 2, we're still going to go through that same process again. So we do need to set our equation here equal to 2. And so we're going to have 2 equals x cubed plus 2x minus 1. And this problem is going to have to cause us to either use our graphing calculators or synthetic division. And so what we can do with our synthetic division is just a fast way of doing our division. We are going to take these coefficients of each term. Now we're missing the x squared, so we'll put in a 0. So we have 1, 0, 2, negative 3. And then we're going to do a weird shape here, and we're going to try to figure out some things that we can divide by. And this is just a shortcut in the method. You do always drop that first number down. And so the first number I want to try, just looking at the pattern of these, would be 1. And from here to here, we will multiply. And so 1 times 1 is 1, and that's going to go up here. And then everything along this row you add. So 0 plus 1 is 1. And then you just repeat this process. So 1 times 1 is 1. And 2 plus 1 is 3. 1 times 3 is 3. And when we add those, we have 0. Now this bottom part here is your remainder. So you can leave that one alone. And we now have this answer, and we're going to rewrite that to be x minus 1. We're actually going to factor this now, and it is always the opposite of whatever sign you see here. And then these remaining will be coefficients, so we have 1x squared plus 1x plus 3. And we're going to say that equals 0 if we need to. Now this right here is going to be prime, so we found that x would be 1. Alright, so if x is 1, well, now we've got a good value to run off of, because we also know that we are looking for, again, we want f inverse, the derivative of that inverse, at 2, which is going to be 1 over f prime of f at, or f inverse at 2. Well, we just found f inverse at 2 is going to be 1. So now we know we have 1 over f prime of 1. So now we need to go find f prime. Well, f prime is going to be 3x squared plus 2. And so f prime at 1 is going to be 3 plus 2. So it looks like we're going to get an answer of 1/5. All right, so let's move on to our next problem. And again, so we're still going to follow along the same procedures. We do need to pay attention that we're talking about from negative pi over 2 to positive pi over 2. So we're talking about these quadrants here. Again, negative pi over 2 to positive pi over 2. And again, this is going to be the x value on the original, which is the y value on the inverse. So I have an equation I can set up here. 1/2 equals sine of x. And sine is negative in this quadrant, so we have to be in the first quadrant. And so that's going to tell me I'm looking at pi over 6. So I know here, whenever I solve this, then that x value is going to be pi over 6. So what that tells me is that my f inverse of pi over 6 is 1/2. So let's think about what we're plugging into again. That means that I'll need the derivative of the inverse at 1/2. Oops, that needs to be derivative of 1/2. So then that means I need 1 over the derivative value of the inverse's value at 1/2. And we just saw that the inverse value at 1/2 is pi over 6. So we're going to do 1 over f prime of pi over 6. And so now we need to look at f prime at x. So f prime at x is going to be cosine of x. So now I need 1 over, and then the cosine of pi over 6 is root 3 over 2, which is going to be our reciprocal 2 over root 3. And you may leave your answer like that. Okay, so more of the same over here with our next problem. We, again, given this a value, so we're really more interested in what the inverse's value is. So we're going to set that equal over here. So I have 1 equals cosine of 2x. And so again, we're talking about just our first quadrant here. So we're talking about something in this area. Well, what in the world could we see here? We could do the inverse cosine of both sides, and that would tell us that we have inverse or arc cosine of 1 equals 2x. And this is asking us what value can I plug in and say cosine of that angle gives me 1, and that's going to be a 0 equals 2x. So here x has to be 0. So now we're ready to go ahead and look at our derivative. So let's look at that value, f prime at x. It's going to be negative 2 sine 2x. And so that's going to be negative 2. And if we plug in that 0, we're going to have sine of 0, which is going to give us 0. So let's think about our formula again. We want the derivative of the inverse at 1, which is going to be 1 over the derivative's value of the inverse at 1. And so we saw this is really 1 over f prime at 0, because we had our 0 value. And this is going to be troublesome because the derivative's value at 0 was 0. Oh dear. So this one is going to be undefined. So really we have a vertical point of tangency there going on. So that's pretty good. Okay, so for this problem we need the derivative value of the inverse at 10. And now they're telling us g is the inverse of f. So again, keep in mind we want to see g prime at 10, which is going to be 1 over f prime of g at 10. That's what we need. So we need to find g at 10. So what we can do here again is let's plug in 10 right here for our y value and solve, because 10 is the y value on the inverse. So 10 on the original, 10 equals 4 over x plus 2. And we're going to subtract 2 over, so I have 8 equals 4 over x. Old Jedi mind trick says you can move those two. So we have x equals 4 over 8, which is 1/2. So now I need 1 over f prime at 1/2. So we need to find the derivative up here. Well, the derivative, we need to rewrite that to be 4x to the negative 1. And now that our derivative value is going to be negative 4x to the negative 2. So we need f prime of 1/2 is going to be negative 4 times 1/2 to the negative 2. Oh dear, that's going to be 1 over negative 4 times 4, which is going to give us negative 1/16. All right, so now let's move on to question 6. Question 6, again, is more of the same. So we're talking about a point, and here we've got the point 3,5 is on the original graph, and so we need to talk about which of the following statements is true about the derivative. And so we know then if 3,5 is a point on f of x, so I know 5, 3 is a point on f prime at x, or f inverse of x. And so we now need to know, well, what is the derivative value? Or let's see, so I need to know what is f inverse of, well, we've got several here to choose from, so let's pick on 5 first. Okay, and again, that's because I know that information here. So I want the derivative of the inverse at 5. Well, then that tells me that I need 1 over the derivative's value. And we know that here again, if we're talking about 5 on the inverse, so we were originally at 3/5. So really that's going to be 1 over 2. It's going to be 1/2. So that looks like that's going to give us answer choice C. Okay, so the next set of questions tells us if f at 3 is 8 and f prime at 3 is 5, what do we know about f inverse? This is a good question. So then that tells me, if I know this much, that means that the ordered pair 3, 8 is a point on f. So that tells me that on f inverse of x, then I have the ordered pair 8, 3. And so I also know that the slope of the tangent line, and this is going to be the slope of the tangent line equals 5, and we know it equals 5 at the point 3, 8. And then we would also know the slope of the tangent line is going to be 1 over 5 at the point 8, 3. We know every bit of that from just what we've looked at with our inverses and their derivatives. Okay, so let's see if we can expand that with question 8. With question 8, we have Here, f of x is x cubed plus x minus 2, and let g be the inverse. Evaluate g prime at 0. So again, g prime at 0, going back to what we know about our formula, is going to be 1 over f prime of g at 0. And I know g at 0 is the same thing as setting this whole thing equal to 0 and solving. So if I do that, I have 0 equals x cubed plus x minus 2. And so we'll need our synthetic division again, which should be pretty straightforward here. Notice that, and if we think about this, x would have to be 1, wouldn't it, in order for this to go to a 0. So that came out a little bit smaller. But just reasoning this, looking at it, x would have to be a 1. And that would give us 1 plus 1, which is 2, and 2 minus 2 is 0. So we can now substitute in that value, and we have 1 over our derivative's value at 1. And so f prime at x is going to be 3x squared plus 1. And so f prime at 1 is going to give us 4. So the derivative's value as the derivative of the inverse's value at 1 is going to be 1/4. Okay, so continuing this practice, we now need to find g prime at 6. And we know that g is the inverse of f. So again, writing out our formula, we know g prime at 6 is 1 over f prime of g at 6. And so looking over at our table, then we see that g at 6 should give us, notice on the original function we have 2, 6. So 6, 2 should be what we're looking at. So I now know I need 1 over f prime at 2. And so f prime at 2 is going to be 1/3. So we know g prime at 6 is going to be 1/3. No, 1 over 1/3. Sorry, folks. This should be a 3 there. All right. For number 10, since it is a calculator problem, we're not to our calculator problems yet. So we can skip number 10. All right. So more finding the derivative of our inverse. So again, remembering that trig formula that we had for tangent, the derivative of inverse tangent was going to be u prime over 1 plus u squared. Here's going to be our value for u. And so very quickly we see that dy dx, or y prime, whichever you want to write, is going to be e to the x over 1 plus e to the x squared, which is going to be e to the 2x. All right, so here with number 12, I would go ahead and write this as x to the 1/2 to help us remember. And so our derivative formula was negative u prime over the square root of 1 minus u squared. And so y prime equals, just to change it up a little bit, we'll use y prime. We have negative, and then the derivative of x to the 1/2 is 1/2 x to the negative 1/2 all over the square root of 1 minus u squared. So that's going to be 1 minus x. And please leave it like it is. More rewriting for this. Again, I would change this value here to be 1/2 x to make it a little bit easier. And the derivative of arc cosine or inverse cosine, that was going to be our negative u prime over the square root of 1 minus u squared. And so here h prime at x is going to be negative 1/2 over the square root of 1 minus 1/2 x all squared, or 1/4 x squared. All right, moving on. Here, the derivative of inverse of x cubed. Again, here's our u value, so y prime is going to be the negative derivative of x cubed, 3x squared, over the square root of 1 minus x cubed all squared. Remember, again, exponent raised to exponent, you need to multiply those. So that's going to be 1 minus x to the 6th. And we're going to leave it just like that. Moving on to number 15, this is going to require the product rule. And that's something we've not seen yet. Here's our two functions. And again, we're going to have all of that great product rule built in. So let's see if we remember it. We have the first times the derivative of the second. And so our u prime over 1 plus u squared, so 9x squared. So there's first derivative of the second plus the second, so we have inverse tangent, times the derivative of the first, which is going to be 2x. And we're finished. Don't do anything else to that. And number 16, oh wow. Now this one is going to be interesting, but it's a great problem. We do need to remember that the derivative of e to the stuff is going to be our stuff prime. So we have stuff prime times e to the stuff. So let's keep that in mind as we're finding h prime at x. We need to do the derivative of this exponent. So the derivative of the inverse cosine of x, that's going to be a negative, and it's going to be 1 over the square root, 1 minus x squared. That's just our formula. So we have, there's our stuff prime, and then times e to the stuff, which is going to be e to the inverse cosine of x. I have a feeling in a multiple choice situation, since this was a negative 1 over, you're probably going to see it written as negative e cosine to the negative 1 of x over the square root of 1 minus x squared. That's probably the most you're going to see that simplified. Okay, our last set of problems on this set. We have, again, another product rule problem. So we have, here's our first function and here's the second. So we have h prime at x is going to be equal to, and we have our first times the derivative of the second. So the derivative of x is 1 over the square root of 1 minus x squared. So first derivative of the second plus second, so inverse sine, second times the derivative of the first. And again, we're going to leave it just like that. All right, so this one is quite interesting. We have the derivative of inverse tangent, but our angle this time is cosine of x. So again, we can do this though. We have y prime equals, and so the derivative of cosine of x is going to be negative sine x over 1 plus that cosine squared, so cosine squared x. And so really the answer looks a lot easier than the actual question itself. All right, again, we have the derivative, and this is going to be our angle, and I would go ahead and rewrite that x to the negative 1 to make it a lot easier for yourselves. And so the derivative of x to the negative 1 would be negative x to the negative 2 over 1 plus all of that squared, so that's going to be 1 plus x to the negative 2. And so again, you're welcome just to leave that. If you do simplify it, the best way to simplify this, if you had to, would be to multiply the top and bottom by x to the positive 2. And that's because if you multiply those, you add those exponents, so that's going to go out to just a 1 there. And then on the bottom, you're going to have x squared plus 1. So that's the quickest way to simplify it, but I don't foresee you having to simplify that. Okay, so again, more of the same. We are going to look at this portion here. So I have g prime of x equals, that's going to be 2x over the square root of 1 minus, and x squared squared is x to the 4th. And that's going to be simplified enough.